Hello everyone, welcome to Dr. Ravi's Academy, and in today's virtual class we'll be solving a problem on resultant of coplanar non-concurrent forces. And this problem, let us look at a truss is given. The name of the truss is a Fink truss, and number of loads, let us look at that. It is 6. It is subjected to 6 loads, all are acting vertically downwards only. So usually, so this constitutes a coplanar non-concurrent forces, and usually in coplanar non-concurrent forces, the procedure is you will be evaluating the resultant magnitude and the direction as well as the position of the resultant force with respect to a reference point. So these are the three parameters you are supposed to determine in this particular problem. So to determine the magnitude of the resultant force, let us write down the expression for the sigma fx and sigma fy. There is no horizontal component in this particular problem. So obviously your sigma fx will be 0. And let us write down sigma fy, the sum of the forces along the y direction, and the notation is standard xy. The forces pointing downwards are negative. So it is minus 200, it is minus 300, minus 400, again it is minus 300, minus 200, and a point load is acting here, it is minus 2100. So if you add all this, it is 2 plus 3, 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14, 14 plus 21, 35. So minus 3500 newtons, which is acting vertically downwards. So when Fx is equals to 0 and your resultant itself is sigma Fy, and that value is 3500 newtons acting vertically downwards. So this is your first parameter, that is the resultant force, and with the direction is acting vertically downward. That means theta is equals to 90 degrees with respect to x-axis. Okay, now you have to find out the position of the resultant force. So in order to find out the position of the resultant force, let us observe carefully from this right triangle. From this right triangle, this length is given, and 10 meters. This is the hypotenuse of this right angle triangle, and projection of this on this is 10 cos 30. Projection of this on this is 10 cos 30. And again, we would like to calculate this momentum for this particular force. So from this right triangle, this itself is hypotenuse. Projection of this on this is this length becomes, this length, it is 10 cos square 30, and 10 cos square 30 is nothing but your 7.5 meters. Now you know the momentum of all the forces. It is 7.5. This is midpoint 15, and this is 30 minus 7.5, that is 22.5, and lastly it is 30 meters. And of course 2100 newtons is 10 meters. Now let us apply Varignon theorem. Moment of the resultant force about point A is moment of all the component forces. So this particular component force is passing through the moment center, and there is no moment contributed by this particular force. So you can write down here 300 about A plus moment of 400 about A plus again 300 about point A plus moment of 200 about A, and lastly moment of 2100 about A. So this is what is your Varignon's theorem. This is Varignon's theorem. So by means of Varignon's theorem, we will be able to find out the momentum for the resultant force. So this value is 3500 into d. D is the momentum, which is equals to your 300. This force momentum is 7.5 meters plus 400. 400 is midpoint, that is 15 meters plus 300. So the 300 momentum is total span is 30 meters minus 7.5, that is 22.5 meters, and 200 into the whole length, that is 30 meters, and lastly plus 2100 into 10 meters. So from this equation, only one unknown and one equation, we can find out D, the moment arm for the resultant force is 12 meters. So you got all the values. You know this resultant magnitude R and the direction vertically downwards and the position of the resultant force. So that is acting at a distance. This is 10 and it is acting approximately here. This is the resultant, and at a distance from point A, it is 12 meters. Thank you for watching this video.